Alright, so today we're going to be having a look at this Commodore VIC-20 computer. For those of you who aren't familiar with it, you may recognize it as looking quite similar to the Commodore 64. This computer was actually released before the Commodore 64, in 1980 originally, I believe. The Commodore 64 came along in 83, maybe earlier, maybe late 82. This has a 8-bit MOS 6502 CPU. This is the PAL version from here in Australia. So it runs at about 1.1 megahertz, I believe. It has 5K of RAM technically, but you only really get access to about 3.5 kilobytes of that in BASIC. I think you can get access to a bit more through an assembly language program, and there are also memory expansions available, which I'll talk about a bit later. Well, I guess first of all, the keyboard is pretty similar to the Commodore 64 keyboard. There was a slightly earlier variant of this that I think had a keyboard similar to the PET, which was the previous main computer by Commodore. But then they switched to this and then continued that through into the Commodore 64. On the side here, we've got some ports. We've got a standard 9-pin Atari style joystick port, so any Atari controller, any controller that would work in a Commodore 64 or an Amiga should be able to work in here. Power. Now this is interesting. So I can tell by this power connector, this 9-volt AC 2-pin connector, that this is an older version of the VIC. I can also tell that from the badge here. The newer variants that came out around the time the Commodore 64 was launching had the little rainbow design that you see on the Commodore 64. This is a bit of a problem for me because I don't actually have a power adapter for this. The power adapter I use for the Commodore 64 would work on a later model VIC-20, but this one, it needs this 9-volt AC, and while the Commodore 64 power supply does output 9-volt AC on a couple of the pins, it doesn't output that voltage at a high enough current. I think this needs 2 to 3 amps potentially, whereas the Commodore 64 power supply only outputs something like 1 amp on the 9-volt pins. So I'll have to do something to sort out power later on. There is an on-off switch here. It seems a bit stuck. I don't really want to force it. There is a little, I don't know if you can see, there's a little latch here that I think gets switched when the power's plugged in. It may need that to be down for this to switch on, but I'm not quite sure. Going to the back, I've got a green sticker here, and what that's for. There is a cartridge port in here. A lot of games shipped on cartridges. Originally this didn't have a disk drive, so cartridges were a common way for commercial software to be shipped. There's 2 ports here, so we've got the video out. It's 5-pin DIN. I'm hoping that the composite cable I built for my Commodore 64 will work fine on this, but if it doesn't, I do have a cable that came with this, which has an RF modulator on it, so I can use that. You note this doesn't have an inbuilt RF out like the Commodore 64 I have does. They may have added that on later versions, I'm not quite sure. There's also a cassette port here. I do have a Commodore dataset cassette drive, so I could try that. And there's the user port. So these are very similar to what you'd get on a Commodore 64 for expansions. Nothing on the side over here. And then if we look at the bottom, well, there's a lot cleaner on the bottom. I think this was definitely stored face up for the previous owner, Wayne. He'd written his name on here and also a phone number, so I've just taped those over just for privacy, of course. You can see serial number, model VIC-20. Attempted repair by unauthorized persons voids the warranty. I'll watch out for that. Disassembly should be pretty straightforward. There's just 3 screws on the bottom. It's very similar to the Commodore 64 here, which I have taken apart before. Before I get to that, the real first step with this guy is going to be giving it a clean. As you can see, it's pretty filthy. I think this was just stored in a garage for a very long time. So I'll definitely need to clean this off. I'll start with that before I take it apart, I think. Just a basic clean to get some of this dirt off the top, but just to avoid it getting everywhere. I don't know what it's going to look like inside. In addition to just the computer, this did also come with some cartridges. So we've got some games. So first I've got Alien. You can see again Wayne wrote his name on this, so I've just blanked his last name out. There is a reason why he's written the name of the cartridge on the top, which we'll see a bit later on. So these cartridges, for those who aren't familiar, will just connect in to the cartridge port here. What else have we got? We've got Cosmic Cruncher. Sounds exciting. We have Gorf. I think this is a Space Invaders clone, or it might be a Galaga or Galaxian, I'm not sure. I think it's the Space Invaders clone. And then these two, which are quite cool. So here we've got these two cartridges. These are RAM expansions. So we just got a 16K RAM cartridge here, which adds another 16 kilobytes of RAM. But then also this Super Expander with 3K. So this adds 3 kilobytes of RAM, but also I think there's some additional basic functionality that gets added here through this Super Expander. It's got some ROM in here that adds some more functionality. So I'll have a play around with this one. Alright, now this is where it gets kind of interesting. This VIC-20 came actually sitting inside this thing. This is the Arfon Micro VIC Expansion. Essentially, when I received this, the VIC-20 was sitting inside it. So down sort of in here, like that. You'll see on the side here, there's this hole, this cutout here, where the on-off switch and the joystick port poke through. And then this backplane here, or motherboard as it has written on it, as you'll see, this was actually connected into the cartridge port. So the VIC sort of slid in that way. Now, this is really interesting. I did a little bit of searching and found some information about it, but not a lot so far. Essentially, this was some sort of third-party add-on sold for the VIC-20 to allow you to do a few things. So the prime thing that this appeared to be used for was this motherboard basically allows you to connect cartridges, but essentially these cartridges would slot down in here, and there was then there's a switching device which I've got over on a shelf with some switches on it, and essentially what I gather is that it would let you just plug in a whole bunch of cartridges, select the switch to which cartridge you want to run, and then turn on your VIC and away you go without having to change cartridges all the time. And that is why some of these cartridges have their the software name written on top. As these were all sitting in a row, it would have just made it easier to see what cartridges you were pulling in and out if you were swapping more cartridges in. What I find really interesting about this thing is I think this thing could actually power the VIC. So this plugged into the user port, and I know the user port does supply power. I'm not sure if it can receive power, but this thing does have a power cable that runs to it. We turn this around, we'll see power switch on the side, looks like maybe a fuse. What's that say? German, I'm not sure what that is. And this port here I think was designed to be used for a printer. I did find some documentation, like some marketing material for this thing. And yeah, I believe it was supposed to, they were going to release a printer for it. I'm not sure if they ever did. There's also, back here, this is the original RF modulator. So I should be able to use that to get video if my Commodore 64 video cable doesn't work. So what I'm hoping is that inside this, there may be a power supply that I could be able to repurpose. I'm nervous to plug this whole thing in and just hope it works. I'm not sure how reliable any of this really would be, because again, it was a third-party add-on. For all I know, I'll just switch it on and fry the computer, and I really don't want to do that. I want to get this thing up and running. Okay, so let's give this a bit of a clean. I'm just going to be using some window cleaner. I've seen a lot of people use this for cleaning these old computers, not this specific brand. I did a bit of Googling. As long as it's ammonia free, which this is, it should be fine to use. Just be careful, some window cleaners do contain ammonia, and that can cause sort of streaking on the plastic, I think. And just spray some on. And let's give this a bit of a wipe and see if some of this comes off. It's definitely getting some of this gunk off, which is good. I'm going to give this a more thorough clean later on, but I just want to get, I guess, just the bulk of this surface dust and grime off, so it's not getting all over my table, all over me as I'm opening this thing up. The plastic seems okay, like it's not yellowed, which is good. In the grooves, it's really bad. I'm not going to get that just now. I would like to get this thing opened up, so I'll just give the keys a quick sort of dusting. I'm noticing now that the base bar is a bit wonky. So, see what's up with that. And also the F1 key looks loose in some way. That's fine. You have to take these keys off to give them a really good clean. I think that'll just get the plate up here. Yeah, it's good, isn't it? Not great, but it's looking better than it was. If I can get this thing working, I'll invest the time into. Well, I might get that off. I'll invest more time into giving it a very thorough clean, assuming I can actually get this thing working. I think that's okay for now. Just get this little bit of paper off. The keys feel okay while I'm here, even that slightly wonky F1 key. Spacebar. So, all right, let's turn this over, and I will get a screwdriver and have a look inside. So we've got 3 screws, and then it should just flip open. Gunk fell out of it. Nice. Now this should just flip open like a Commodore 64. Now just got to be careful of the cable connecting the keyboard. Let's just disconnect this keyboard ribbon. Well, not even a ribbon, it's just a whole bunch of cables tied together. And this down here, I think that's just a power LED. There we go. Okay. So, keyboard connectors here. I like the little looping around of the rainbow cable. Okay, but yeah, pretty standard. Looks very similar to a Commodore 64. There will be the shift lock. So on these keyboards, the caps lock key is, you'll see it sort of sticks in and stays in. It's a physical switch, and it basically just permanently keeps the shift key down. You actually need to desolder some connectors to remove this bottom of the keyboard. This is interesting. This leads me to believe that I can power this thing on using the Arfon Micro. And what I'm talking about is this cable here. So based on my reading, powering on the VIC-20, we've got this 9-volt AC connector. That is then going to be regulated down to 5-volt DC, which is what the majority of the VIC uses. The 9-volt AC, I think, does get used for the data set, so the cassette player, to drive the cassette motor. But other than that, nothing on the actual computer needs that 9-volt AC. I think the Commodore 64 uses the 9-volt AC to drive some timing on the video chip or something like that. I'm not sure of all the specifics, but this only actually needs 5-volt DC to run. Now this here, I'm pretty sure is not stock. So let's remove this. Have a look now. You'll remember I mentioned that Arfon VIC Expansion, how I thought maybe it would route power in through the user port. And this is kind of looking like it does. Yeah, so got some pins here. This looks like it might have been added on later. And then over here, we've got similar, a little 2-pin connector down there, connected, which I'm pretty sure is going to be feeding 5-volt into the 5-volt rail. So if that's the case, I should be able to power this thing on, I think just by driving 5 volts here. I don't need to go through that 9-volt connector. So this might be an option for getting power. Even if I can't do it through the Arfon, if I don't trust the Arfon Micro at this point, I should just be able to connect 5-volt DC here, through here, and power it that way. So I will have to do some research before I try that, because again, I don't want to, damage anything. But that's looking promising. I'll just plug this back in for now. Okay, so let's have a look at the board a bit more closely. So this is the CPU down here, the 6502. It is socketed, that's nice. A lot of these chips are socketed actually. Okay, so we've got the CPU. These are the I/O chips. None of the pins look particularly corroded. Looks like it's actually in pretty good condition, I'll be honest. Dusty. I will need to give this a bit of a dust. But yeah, I'm pretty happy with the looks of all this. Give all the chips a bit of a push. Yeah, they're all pretty well socketed. A little bit of a crack as I push them, but nothing major. Just checking to see that there aren't any leaky capacitors anywhere on the board. I mean, at least at first glance, it all looks okay. I will check some of the schematics and confirm that driving 5 volts in here is actually what I want to be doing. Alright, that looks pretty good. Time for a short research break to take a look at the schematics. So I found here on zimmers.net, which is a pretty good resource for schematics for lots of things. I found the VIC-20 schematics, and I found here VIC-20 Revision B PAL old design. So this is the motherboard that I've got. So if I take a look at these, we can see full schematics for the board. We can see it is a bit blurry, not the greatest scan, but it's good enough. Now, I looked over this for quite a while, trying to find the relevant points of interest. Eventually, I was able to decipher it. I'm still pretty new to figuring out these circuit diagrams. So, 2 key points are here. This is the user port, and up here is the power supply. If you're looking for a power supply in a circuit diagram, particularly if you know you've got AC coming in and DC being used, the key thing to look for is this little diamond diagram. This is a bridge rectifier. So this is basically just 4 diodes set up in a pattern to allow you to convert alternating current into direct current. So if you see this, you're probably looking at the power supply. The key points to note are, if we zoom in on the user port, we see the list of pins. Now they're not listed in order here. So you'll see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now these pins are actually 1 to 12 and then A to N on the actual device itself. So it's 1 to 12 on top and then the A to 12, A to N on the bottom. But the circuit diagram shows these just in an order that's more convenient for the circuit diagram. Important thing to note is down here, we have CN1, and we'll see it's connected to pins 10 and 11, and is connected to the AC 9 volt rail. So these pins are where 9 volt AC is expected to be sent out on the user port. CN1, this label, corresponds with the CN1 label that's actually next to the port that we saw with that cable plugged in. Right, so now if we zoom in on the power supply, we see we've got the power jack, comes in through 2 inductors, power switch, fuse, there's a capacitor here which I think is a power filter, just to smooth out the power coming in. That then feeds into the bridge rectifier to get the DC signal coming out, which is then regulated down to 5 volts over here. But if we look before it gets to the bridge rectifier, when we're still just on the straight up 9 volt rail, we see connector CN2. Now, connector CN2 corresponds with the connector where the other end of that cable was plugged into. So we can actually see from this that if we look at the big diagram here, what we can imagine is that there is a cable running from CN1, and that cable runs all the way to CN2 up here, bridging these 2 connectors. This basically means that both of these connectors are bridging the 9 volt rail. So what we were really seeing there was support for passing 9 volt power in through the user port and routing that here. So it basically bypasses the power jack entirely. One thing of note is that means that the fuse is being bypassed, but we did see that Arfon Micro did have a fuse in it. Also the power switch is being bypassed, but again the Arfon Micro has a power switch on it. So essentially the Arfon Micro cuts out this section here and connects that in through the user port. All in all, that was a pretty fruitful research break. So from the looks of things, this that connects into the user port will in fact be supplying 9 volts AC directly out of here, which will then run, it will run from these pins here. These 2 pins deliver 9 volt AC into the board instead of out of the board like they normally would do, along this, all the way to here. This should be a connector on the 9 volt AC rail before it goes into the bridge rectifier. Cool. Let's clean this up and get it flipped over and see if we can have a look inside the power supply. So this here is the RF modulator, also very dirty. Switch selector, channel selector, sorry. So I did think about taking this off, but it looks like if I flip this over, I can actually get into this, or I can remove this completely. And this is a bit of a pain to get off. Although, it does look like it's actually soldered. Its power supply is soldered on, so maybe not. We'll remove this. Now from memory, there are actually some nuts on the bottom. So these screws go into these nuts. So removing these is a little bit tricky. I'm going to do that off camera. So I've removed these screws. A couple of the standoffs came off as well. This just lifts off. You can see there's a few more plastic standoffs that the screws or bolts went through. So we'll keep those safe. we can turn our attention to trying to get this power supply open. The first thing I'd like to try is, can I just open it? Doesn't seem to want to open. There must be some screws. What we're going to do, we're going to carefully flip this over and have a look at the bottom. So we can see there's 4 screws here that are actually holding the power supply into this frame. So I'm going to remove those first. You can actually see here, made in Wales. Now, that's actually coming off, but I think that's just the cover. So I assume the transformer is probably going to be wired down here, but let's have a look. Doesn't want to come off. There we go. Oh. So there's, looks like some cable getting stuck. There we go. Okay. We've got this removed. Okay, what do we have? We've got the power switch here. This would be the fuse. This must be the power out to the printer. Which they possibly never made. Now, what's this? I'm not sure what this is. This here. There's a couple of capacitors. And it's wired to something on the outside. I'm not sure what that actually is. I am not an expert at electronics. If anyone can tell me what that is, I'd be interested to know. But anyway, we have this transformer here, which I assume is doing the 240 to 9 volt transformation. Mains comes in here. Out of this, we've got, I think that's a capacitor. What do we have coming out here? Oh, is that doing a DC transformation? That could be a bridge rectifier over here. So the current's coming out of this transformer, and then some of it is coming out here through this. Now I assume this is going to be the 9 volt AC, but I don't really know what this is. I don't know if this is actually doing anything or if this is just distributing power. I'm tempted just to plug this in and then maybe do some multimeter tests of this. I mean, it might be a terrible idea, but it doesn't look too bad. That capacitor's probably fine. Yeah, I'm going to plug this in and give it a try. Alright, so I've got the mains hooked up. I haven't switched this on yet. I've got the motherboard sitting off separately so that power going to it doesn't get shorted. I did consider desoldering its power connector, but I've decided that I'll just risk this. On my head be it. Alright, so I have the actual mains connector here, ready just to yank it out of the socket if something goes wrong. What I'm just doing at this point is basically just a test to see if anything goes wrong. So be careful if you're dealing with any sort of old power supplies, and just, be prepared for things to go wrong. Alright, we have a switch lit up here. Nothing seems to have exploded. There's not much here to explode. It's just a transformer, some sort of large cap. There's no complex power supply here with things to go wrong, and this fuse here should sort out any problems if there was a big power draw. Okay, I'm going to switch that off for now. Now I'm going to get the multimeter and I'm going to test to see what sort of power we're getting out of this. Okay, so I have the multimeter set up for AC volt readings. Now, this is going to plug into the motherboard this way, and I believe it's these two top pins here, that will be carrying the voltage. So let's have a look. Power is on. Arrange the pins. There we go, 9 volt AC. Wonderful. That's what I want to see. That's a good sign. This might actually work. Alright, so we're going to take this connector. Keeping in mind this is going to be giving us the 9 volt on these two pins. And we're going to connect this to the user port. Now, these two pins here, it was pins 10 and 11, are the 9 volt AC, which will then run through this connector here. Okay, so that is connected. Now I'm going to plug the mains back in. I'm going to hit the power, and we're just going to see if this thing, you know, if there's smoke, basically. I don't think there will be though. Based on what I can see, this should be pretty good. Okay, the mains is plugged in. I again have my mains cable ready to pull if something goes wrong. Okay. Nothing seems to have exploded. Just give it a minute. Just feeling around if anything's hot. Seems okay. So I'll try connecting the power LED and see if we get a light. Okay, so we have the power LED connected. When we power on, we should see that here. I'll reconnect the user port. Okay, let's see what happens. And the power LED has lit up. That is a good sign. Moment of truth time. We have the VIC. We have the power supply. I have the power supply connected through the user port. I have my AV cable. It's just composite video cable that I usually use for my Commodore 64. I'm assuming it will work. Let's see what happens. There we go. It works. The VIC-20 runs. Awesome. That was actually much easier than I was expecting it was going to be. Let's just see if it actually works. Let's see if the keyboard works. Boom. I'm sure that auto breaks after a while. I'm not sure if it's supposed to do that or not. Anyway, let's get a game plugged in and see if this works. So I have joystick plugged in. This is not an era appropriate joystick. It is the one I bought recently for my Amiga. Same connector and the same style of joysticks. And we're going to try Gorf. There we go. Okay. Aha. It's Gorf. Okay. Oh, didn't work. Something does not seem right there, does it? I'll try without the joystick. See if we're getting any sound. Doesn't seem like it. It's moving the whole screen when I move the joystick. And it's crashed. Okay. I feel like maybe there's something wrong with this. I'm going to do a bit of investigation. And I'm going to leave it there for now. There's definitely something wrong with this VIC-20. I did do a little bit more playing around with it. I found that BASIC was crashing if I was scrolling the screen too much, and I was getting some graphical corruption in some of the characters. I tried reseeding all of the chips to no avail, so I'm going to need to pursue some other investigation avenues. Stay tuned for that in the next video in this series.